Hey, hello everyone. Today we wanted to talk a little bit about Lelantus Spark, which is our new privacy protocol that we've been working on. That was, it's going to be replacing. We were supposed to go to Lelantus version 2, but then we decided to go through Lelantus Spark directly. And today, we have the great pleasure of having Aram Jivanyan, who was the creator of Lelantus version 1, version 2, and also Spark as well. And we also have Dr. Aaron, who is from Cypher Stack, who is on a full-time contract with Firo. And together they've been working out to make Lelantus Spark, a great new
Wow.
privacy protocol. And perhaps we can maybe start with Aram and talk a little bit about how the differences between the Lelantus version 1, which is what we're using right now, Lelantus version 2, which is what we were supposed to move to, and then a bit about what we were trying to achieve with Lelantus Spark. So all yours, Aram.
Oh yeah, sure. So hi everyone. So Spark has been created to solve one very important problem existing with Lelantus for 2 years. When we created Lelantus V1, so it lacked the feature of direct anonymous payment. So you could kind of mint and spend coins of different amounts, but it didn't enable direct anonymous payments. Actually, it did. I had some algorithm to do that, but Dr. Aaron quickly broke it. Right? You remember? You kind of find a very serious issue with the existing direct anonymous payment construction. And next, like after struggling to solve this issue for more than 1 year, I came to another solution which allowed to do direct anonymous payment. Like you could anonymously send coins to the given recipient address. But this construction, which came to be Lelantus V2, it didn't support another very important feature, which is self addressing, or in other words, it didn't allow recipient privacy. So in order to do a direct anonymous payment, you should take the recipient address, and that address becomes part of the transaction in explicit way. So someone can always trace the number of transactions sent to the same address. Of course, we could kind of ask the users to use different addresses to receive many transactions, but that kind of violates the user experience. That's not good. So Lelantus Spark now solves that problem. It solves the problem of recipient privacy, but it also supports another important feature, which is multi-signatures.
Okay,
So
yeah.
this is
So
how these three different iterations of the same protocol differs.
all right, cool. So, but perhaps before we dive into it, because a lot of probably the listeners and the community may not be familiar, what stealth addressing and
Mhm.
recipient privacy is. Perhaps, maybe Aaron, do you want to have your take on that? Yeah.
Sure. So, like Aram said, ideally, what you don't want is for recipient wallet addresses to appear on chain as part of a transaction.
Mhm.
And for the original Lelantus version 2 protocol design, they did. So you could look at a transaction, and among all the other information that's kind of contained in that blob of transaction data structure that gets posted onto the ledger was the actual wallet address of the recipient. So that leaks a lot of information about the fact that a transaction goes to a particular recipient. And so a solution for this is to effectively take those recipient wallet addresses and not include them in the transaction. Of course, it's problematic in some sense because the recipient needs to be able to receive this transaction, later have the authority to spend those funds. And there's different ways to do this. One of which, like Ram said as well, if you just use a different address provided, or a person who might want to fund, it's one way to do it, but that requires a lot of activity between you and the people who might want to send you funds. So if you're a retail, per customer, or you might need to have them different per transaction, and that's kind of a big pain in the butt. So one approach is called stealth addressing or non-interactive one-time addressing. And using this, wallet addresses don't on the chain, and you can still have just one main wallet address. You can have multiple ones, of course, if you want. But what happens is the sender of a transaction goes through some math using that wallet address and basically prepares a one-time address without ever having to consult you first. And that one-time address is basically what is effectively used and put into the transaction. And then using your wallet address as the recipient, you can recover the information needed to later spend those funds. So it's a non-interactive process. You don't have to start kind of keeping track of all sorts of different addresses per client or per customer or anything. So it's quite nice. It's kind of a similar structure as to what you see in Monero or in shielded Zcash, for example. Although the math ends up being a little bit different, but the basic idea is still the same. That you want all the transactions on the chain to ideally look as similar and indistinguishable as possible. And that also includes not having wallet addresses directly included.
Right. And I guess like a typical use case, without this type of stealth addressing, even though like Lelantus version 2, hit the source of the funds and even hit that, even let's say if I'm receiving the money, I can't see the amounts, and I also don't know when that person spends the amount from that Lelantus version 2 address. But in certain cases, it can reveal quite, there's some sort of like metadata leakage, right? Like for example, if I put out an address on my website, right? Anytime someone sends me a payment, everyone would know that I have received a payment. They would not know the amount. They would not know where it came from. They would not know when I've moved the funds. But the fact that I have received something on this address would be public for everyone to see, as opposed to, let's say, if I'm using, like a stealth addressing type of system, I place it on there. What Aaron and Aram has been saying is that you can't take that address, look it up on the blockchain, and say, oh yeah, when did this address receive something? So it does. I do think it's a very important component of like a holistic privacy protocol system, and that's kind of why, one of the main motivations of why we wanted to do Spark. So I guess we can move on to something that we've been talking about, and I guess is quite topical now, is the support for multisig, right? So maybe Aram, could you maybe like explain what is multisig and perhaps why it's important? Yeah.
Actually, this problem was brought on table by Dr. Aaron when we were researching this new version, trying to solve the recipient privacy problem. Aaron just mentioned how important it is also to support multisig. Because, especially in business application, you would love to have many people having control over the spend process, and which requires actually to delegate the signing process to multiple parties. So no single malicious party will be able to do any spends without the loans of others. Am I correct, Aaron?
Yeah, I mean, that's a good way to think about it. I mean, there's a couple of different reasons that you might want to do this. There's some kind of off-chain protocols that require, effectively like multiple parties or multiple different algorithms to kind of interact to control funds. But like you were saying, another application would be, for example, the classic example is, a business where you want, multiple directors or something who jointly have control over a wallet address's spend key, to basically require them to interact and basically both authorize a transaction.
Right.
Which is a simplified case. There's other ones too.
Or stuff like Quadriga happens, right? Like one guy just, disappears or runs away with the money. And then, it's good to have an additional control over especially if you're holding large amounts of money or holding funds for other people. So, of course, that can be done on the transparent side, like, the normal Bitcoin type of addresses that Firo has. But it'll be nice, as we want to move towards mandatory privacy eventually, it's good to have this functionality built into our private addressing system. And I guess like, has been quite a topical thing. Like, I think this is something that we maybe previously underestimated the importance of. And I think like, Dr. Aaron has had some experience like, with Triptych, right? So do you want to talk a little bit about that? Yeah. Like why did
Yeah, I
the
mean,
company found Multisig?
Triptych is another, Triptych is another private transaction protocol with a similar kind of underlying proving system plumbing in some ways to Lelantus Spark and to other research that I had worked on. But the way that its math worked made multi-signature operations much more complicated. You could do it, but it's very complex. It requires some math that you'd probably really rather not have to implement. And it might not be suitable for things like low-powered hardware devices to do. So ideally, you want the math to support multi-signature operations in a really clean and simple way. And Lelantus Spark lets you do that. So that's very nice. That means that the interactivity between different parties that need to jointly compute a signature is very straightforward. It's pretty straightforward, like it is in other protocols, to generate the initial kind of address structure to jointly control an address. And again, like this is also very nice for low-powered hardware devices that may store, in this case, a portion of a secret spend key, but might not have the computational oomph to do a lot of complicated math or proofs.
Yeah.
So it's nice that this can support that very, very cleanly.
Yeah, I mean, because I think, it's very unlikely for something like a Trezor or a Ledger, which is almost like basically like a thumb drive size thing. It's not going to have like a lot of CPU power to do very much else except the most simple operations, right? And I understand Dr. Aaron you've been working on ways that we can offload certain computations. I mean, it's a slightly separate issue, but it's, I guess, related, where we can offload a lot of the heavy computation to like, your regular PC or your mobile phone, while still having that signing authority be left with the hardware wallet, right? Yeah.
Yeah, and maybe when you want to talk about some of the kind of key structure in the Lelantus Spark, I can talk about that in more detail.
Okay, that sounds good. Okay, well, I guess this would be a great time to maybe talk about, I mean, like the different type of what is a viewing key, what should we, why should we want viewing keys? Why is it important? I don't know. I mean, either Aram and Aaron can start with that. Yeah.
Yeah, Adam, please go in.
Sure. So in Bitcoin type protocols, you have effectively a public address, and you have an associated secret spend key that goes with it. Okay, can you still hear me? Okay, I thought I froze for a second. Never mind. You have a public wallet address and a secret spend key that goes along with it, and you can use the public address effectively to scan the chain and see what funds are directed to that address, and then use the spend key to then spend those funds. But of course, there's a lot of visibility that goes into having that public address on chain, as we've said. So in Lelantus Spark, similar to Zcash and similar to Monero in their protocols and their constructions, there is a view key. And in fact, in Lelantus Spark, there's up to 2 view keys that let you, the device that you're using, or a designated third-party service or device get certain kinds of view-only access into transactions that are associated to your wallet address without giving spend authority and without making that information, transparent and public on chain. So in the Lelantus Spark, there's an incoming view key, and then there's a full view key. So an incoming view key works similar to in Monero, their view keys, and similar to Zcash incoming view keys, where if you delegate that key to another party or device, that party can then scan the chain and see what coins are destined for your wallet address, as well as any associated memo type data that might be on them, as well as the amounts. And that's very useful because in one case, maybe you want to delegate out to some third party that has a lot of computational power, the ability to scan for transactions and notify you. For example, if you're a retailer or something.
Your accountant, right?
Yeah, exactly. It's you could, that entity could scan and watch for transactions that are destined to you. And kind of another model, even if you're using kind of a full wallet that has access to your spend key, you probably don't want that spend key, to be open and available in memory all the time, for example. So it's very nice to be able to have that key kind of locked away and encrypted in however you want to store it, while still, allowing for, this kind of trustless scanning by the wallet as transactions come in. So yeah, you have some nice functionality there. However, that doesn't guarantee you the ability to see when those funds are spent. So, there's some ways that you can kind of try to infer what the balance of an account is just from that view key, but it's not perfect. And kind of the ability to have an outgoing view key is supported by some of the Zcash protocols, but the Monero protocol doesn't currently support that. And it turns out it's kind of tricky to get that right. But in Lelantus Spark, we figured out one way to do it. So that's kind of another related viewing key. And in conjunction with the incoming view key, so it kind of works together with it, what you can do is you can identify when incoming funds are later spent in a transaction. It's limited what you can see about that. For example, you can't see right now, what the outgoing address is, but you can see that a coin of a certain value was spent in a transaction. And that lets you determine the full balance of an account. So that could be useful, for example, for your accountant to have, for example, or maybe you're a public charity and you want your funds, to effectively be visible. So, the public or your donors can see, what the balance of your, the public charity wallet address is, for example. So that's quite nice. Another application might be in this multi-signature case, where if you're part of a group of signers, and if you have it set up in a so-called threshold case where certain groups of signers can authorize transactions, you might want to know if another group of signers, authorized a transaction that you weren't a part of. So there's all sorts of nice applications for this. And again, this view access, whether it's incoming view or full view, doesn't delegate spend authority. So, folks might be able to identify when funds are going in and out, but they can't spend funds from your address. So that's pretty cool. And then finally, there's one other type of key called the delegation key. And this relates to what Ruben was saying earlier about, some of the benefits of wanting to use a low power hardware device. So Lelantus Spark transactions include several different components, one of which is this so-called one of many proof. And that's basically what gives you kind of the spend signer ambiguity of the transaction. And that can be a fairly computationally expensive proof. It's probably not suitable for a very low-powered hardware device to do. So what you can do is you can take this so-called delegation key, and you can provide it to a semi-trusted device like a higher-powered computer, a desktop or a laptop or something. And that device can generate most of the expensive parts of a transaction, but without being able to kind of finalize it and actually complete a spend operation. So a low-power hardware device could offload this expensive computational stuff to its higher-powered, PC counterpart, for example, and then later, just do the very cheap computational work of doing the final authorization of a transaction with the spend key. So the spend key basically gets to stay as secure as you want it to be. You can delegate and offload this other kind of view or proof generation authority to a higher power device with limited trust.
Right.
So very flexible.
So I guess, like, in a nutshell, this incoming view keys, that means you can see what's coming in, and then you have outgoing keys, then you can see what's coming out, and together you can get the balance of a particular address. And there's also the possibility of a delegation key, meaning that as Dr. Aaron said, that I have this low powered device that I want to have the spend to like authorize the spend, but all that private the complex computations that is required to do your the private transactions can be done on a more high powered device. So I do think this is really important. I mean, a lot of people say like, oh yeah, you're a privacy coin, why do I need view keys? I guess the idea to me is like privacy is about being able to selectively review what you want to review, and view keys allow that. While if you don't have that functionality, it gets really tough. Like as one of the examples that was quoted, like if I want to pay my taxes or I want to send it to my accountant, I can't really do that in a trustless way. I would have to give them spend authority as well, which is not great, right? So I think this is it's a really useful thing, and I do think it's going to be like a when especially when cryptocurrency gets more matured and stuff like that, this would be a very important component as as a cash, right? So yeah, let's move on, and we can talk a bit about what's the kind of like current status of Lelantus Spark, Aram? Like, we've worked a lot about it, but it'll be great to hear from you. Like, where are
Yeah.
we at in Lelantus Spark development or like creation? Yeah.
Oh yeah, sure. So I think we are progressing quite well on the paper now. So the Lelantus Spark is using different cryptographic building blocks. For example, a modification of one out of many proofs. We are using a special Chown-Peterson type proof for supporting the multisig functionality, and all these cryptographic building blocks are coming with a security analysis. So all blocks are probably secure. And also we are working on the security properties of the whole payment system. So we showed that the payment system so Lelantus Spark as a payment system, it will kind of preserve the balance properties of the whole transaction. It will uh, allow transaction non-malleability, so it will be probably be secure and shown that no one can kind of forge the transactions and redirect someone's transaction to other recipients. So now we are finalizing the security proofs, and I believe the paper will be out very soon. And also, Dr. Aaron is working on proof of concept implementation of the protocol, just to see how all these different modules come together. Right, Aaron?
Yep. Yeah. So just a proof of concept, code that could help, any future deployments, as well as help folks kind of figure out how it all fits together. And I always like it as kind of a nice confirmation, of how, like you were saying, all of the building blocks have to play nicely together. It's one thing on paper, but it's another to actually be able to kind of run some tests. And of course, that's nice for providing some of the details that would be useful in any future deployment.
And I believe also that the implementation will give us important insights about its performance, right? Because although we can kind of theoretically estimate what the performance will be, but this real implementation will support the theory and will give us insight what is the performance of the system.
So like, I mean, we call this protocol the Lelantus Spark. It still has the Lelantus name, but like in its back end inner workings, how similar it is with like previous versions of Lelantus. Like as I understand it, it's almost a completely different construction. Of course, we did want to keep the Lelantus brand name, but maybe a little bit from Aram about like I mean, without going into too much detail, like how similar is it, and does it retain any sort of similar concepts between the two? Yeah.
Yeah. So I'm a bit biased, of course, but in my opinion, these two protocols like Lelantus Spark and Lelantus V2, they are both very similar, and they also differ significantly. They are different because Spark is kind of the natural iteration of Lelantus research process, and all the concepts and ideas are kind of chained together, although it has evolved. And now the new protocol is relied on kind of different cryptographic constructions, but the main construction is the same. So it relies on so-called one out of many proofs, modification of these proofs. But to give an example, the first version of Lelantus was relying on a so-called double-blinded commitments. That was a generic cryptographic commitment which allowed us to commit to the coin secrets, such as the coin value or the serial number, through a single cryptographic element. Now we had to get rid of that construction and using more standard commitment approaches. And that comes with some cost. All these features comes with some cost, which is the verification of transaction will be a bit higher, approximately 40% higher, if I'm not mistaken. But yeah, so they are both very similar and also very different now.
Sure. And I mean, it also does come with a lot of benefits, like especially the way it's kind of separated out the balance, the separate out the construction allows it to be more modular, right?
Yeah,
And
I
and
believe this is the favorite part of Aaron.
yeah, so maybe Aaron,
Yeah,
you want to
please.
talk a little bit about
Yeah,
that? Yeah.
Yeah, so one nice thing about this design, compared to the earlier Lelantus approaches, I think, is that it definitely is more modular. So, like Aram was saying, we have the idea of these one of many proofs. Balance is taken care of by a particular kind of representation proof. There's this other kind of Schnorr-like representation proof that's used to show things about linking tags that are used for double spend prevention and things like that. And having those building blocks separated is nice for many reasons. It can make the analysis a lot easier. So, for example, being able to show properties involving balance, and other security properties is likely going to be a lot easier because of this. It also means that, in the future, if any of these building blocks become more efficient, for example, if we can do a more efficient one out of many proof in the
yeah,
future, in theory, you could swap that out. The protocol, design, while it would change, would not lose its security guarantees. So modularity is really nice.
Yeah,
You
and
can get more efficiency
yeah, I
later
agree.
on without having to sacrifice, a lot of other, tedious analysis or redesigns.
right. And I think it's also like one of the key elements that I guess may have allowed like the view keys, the multi-sigs, because the addressing structure, if I'm not mistaken, used to be tied very the commitments. I think it's better that it comes from you, but it was like everything was kind of tied together.
Yeah,
And
those double-blinded commitments that Aram mentioned, it allowed for a lot of really nice efficiency, particularly in
Yeah,
the so-called one of many proof, because you were basically kind of lumping together information about the control of the spend and some randomness, and also the value into one single unit, which was very conceptually nice, but unfortunately did lead to a lot of limitations that made things like recipient privacy and even some things involving balance much more challenging to analyze or to extend. In this case, we take more of kind of a Monero protocol style approach where we basically kind of separate out the kind of spend control information, the so-called serial number, and then we separate out the amount information into a separate commitment structure. And that provides a lot more flexibility. So it can enable things with with the proper addressing, can enable things like this view key functionality, nicer multi-signature approaches, and particularly balance is a lot easier to show.
oh, yeah. So maybe like on a very high level, right? Because obviously
yeah,
a lot of people will be asking like, well, how does this compare to the kind of other privacy protocols that are out there? Like, there's Wimble, there's the Ring CT stuff, there's the different versions of ZK Snarks, or even like the upcoming Orchard. How does Lelantus Spark fit into all of this, right? I mean, obviously, we're very pro, basically any sort of privacy innovation or any interesting approach is valuable in the space. But obviously, there are certain things that we do better, certain things that that Lelantus Sparks can provide. So it'll be good to hear from Aram first, and then we can hear from Dr. Aaron after. Yeah.
yeah, sure. So I believe the one of the most important advantages of Lelantus and Lelantus Spark over Zcash, for example, is that it doesn't require any trusted setup procedure, and also it relies on very well-studied standard cryptographic assumptions. Unlike Zcash, which is ZK snarks, which are relying on relatively novel cryptographic assumptions. And compared to Ring City, I believe the advantage of this Lelantus family protocols is they can support higher anonymity sets, so they can provide higher anonymity because of more efficient one out of many proofs, which are more efficient ring signature constructions. Maybe Aaron will correct me if this was not the right statement, but so snarks provide kind of anonymity between Monero and snarks, So where snarks provide anonymity over the whole set, right? There can be your spend can be hidden among 4 billion minted coins, and in Monero it is hidden among 10 or 11 selected coins. We can support anonymity sets of up to 65,000, which is pretty good.
Yeah. Yeah. Dr. Aaron, anything to add to that? Yeah.
Yeah. So ring CT is kind of a generic-ish approach that takes some different building blocks and puts them together. And there are different approaches to kind of extend and modify that. Like as was said, the current instantiation, for example, in the Monero protocol, uses currently a signature construction that I helped to co-author that is more efficient than what they had. But like Aram said, in practical terms, it's kind of limiting because of the way that the math works, what the effective size of the input ambiguity sets for a transaction can be. So in theory, that could scale as high as you want to go, but you end up running into practical proof generation and verification limits. And there are ways to kind of extend that and modify it a bit that use kind of similar one out of many proofs as well. But as was said, kind of the initial approaches that have been tried, there also had limitations for things like multi-signatures that Spark is able to avoid by changing up some of the design. Whether or not, and again, like Aram mentioned supporting 64,000 big anonymity set sizes. In theory, you can make that as big or as small as you want. It's like there's some inherent limit into that. But again, verification and generation limits, eventually you're going to have to hit those. And part of that, I think, depends on what your goals are, what devices are going to be, operating the protocol. And of course, just kind of like what is the overall scale of the system that you're working with. And there's some ways you can choose those input ambiguity sets in a clever way that let you do some fun and clever optimizations. So I think the nice thing is that there's some flexibility in how that works. And I think that at the scale that Firo wants to deploy it, you could support pretty large input ambiguity sets. And as was stated, there's no trusted parameter generation, unlike Zcash Sprout and Sapling protocols, and Blossom, I think, was the most recent one, which is nice. Zcash Orchard, I know, is a work in progress protocol that uses some different underlying constructions that would not require such a trusted parameter generation process. I don't really know much about, I guess, what its kind of practical implementation results are going to be in terms of size and generation and verification time. So I can't really speak to that. But being able to avoid things like trusted parameter generation with a nice straightforward design is definitely a benefit at any rate.
And I don't know if I don't think Mimblewimble has managed to solve like the interaction like between sender and receiver. Like both parties have to be online, and there's no I don't think there's there's no they say there's no address, but it's more like there's only like a one-time address type of thing. So I think that's a big drawback. Of course, with the the existing way that it can be linked in certain cases. But yeah, Mimblewimble's great for keeping a very compact blockchain. But I think in privacy has been, well, in my personal opinion, hasn't really taken off because they haven't found a way to do aggregation in a way that you can kind of find out how stuff has been aggregated. So I don't know. Correct me if I'm wrong, or
And probably worth to add that it simply lacked transaction anonymity, and that's why Beam has created a kind of symbiosis of Lelantus and Mimblewimble to solve the transaction linkability issue.
Right. Yeah. I mean, Lelantus Mimblewimble is, I guess, like a different flavor of Lelantus, still using one of many proofs that they saw the linkability of Mimblewimble as a drawback, and they added Lelantus Mimblewimble as a opt-in premium feature. I have no idea how many people are using it, but I personally think that we should be sticking to one privacy protocol, and it just simplifies the whole user experience rather than having to switch between this and that. But I mean, that's just a matter of design choice and preference.
The lesson here, I think, is that one out of many proofs are a very nice cryptographic building block.
Yeah, that's right.
You know,
And
they can be used in a lot of different. They can be used in a lot of different ways. You know, Triptych, for example, uses it in a slightly different way as Lelantus Spark, which uses it in a different way as Lelantus 2 did, which uses it in a slightly different way as other approaches might.
Yeah, and it's really funny because one of many proofs was, I think the paper was in 2014, and I remember that when when we first started working in it, especially with Aram, he was tasked to find like the Firo's next privacy, or as we were then Zcoin's next new privacy protocol. We were kind of laughed at, like, why are you looking at this thing? There's all this ZK snark stuff. Why you're looking at one of many proofs? But I felt that especially with the work that Aram and we did in the Lelantus, really kind of like revive interest in this one of many proof types or applications to show that, hey, in actually many certain cases it is pretty efficient without all this fancy trusted setup and moonwave that Graph 16 requires.
Yeah, I believe the key important role that has played there was the efficient page verification technique.
That's right.
Showing how thousands of one out of many proofs can be verified in batches, which making them quite efficient.
Yeah. All right. So let's talk a little bit, because we've been talking about more like the design, what kind of features that this construction enables. It would be nice to kind of talk about some of the stuff that we may not have finalized more on the implementation side. For example, how would we move from existing Lelantus version 1 to let's say a Lelantus Spark system. Now, again, this is all still like work in progress. So whatever we say is just like, we are aware of the risks, and there's some certain things that we are still working on. But I think it'll be just good to like conceptually approach them as to what are our options actually. So I guess we can hear from Aram and then hear from Aaron. So yeah, Aram.
Yeah, I think there are at least two options. The first, more naive approach would be simply asking the user to spend the Lelantus coins and mint them to Lelantus Spark coins.
Yes.
And the second approach could be implementing some transition between Lelantus V1 coins and Lelantus Sparks. From cryptographic point of view, this can be done very easily, because kind of the coins which are represented by cryptographic commitments, like in V1 they are double blinded commitment, and in Spark they are two different commitments. You can kind of create a probable way that new coin is corresponding to the Lelantus V1 coin. But what are the privacy drawbacks of this transition scheme? They should be evaluated. Or maybe Aaron has a different opinion on it.
I think Aaron has done maybe some work. I'm not sure. Maybe Aaron, do you have any additional insights on I guess the trade-off?
I mean, like Aram was saying, there's basically two ways to do it. One way is to start with kind of known plain text values. For example, if you take transparent funds and pull them into, for example, this hypothetical new Lelantus Spark pool of shielded type coins, then that's one pretty straightforward cryptographic approach. In some sense, the math behind it would be kind of similar to the math behind mining, right? Where you have a known amount and you're pushing it into this shielded pool of coins. The benefit there is like you know what the amounts are, what's going into the pool, and there's benefits to that, as well as the cryptography being a bit more straightforward. And the other approach, like Aram was saying, is to basically kind of build a new direct transaction type that would take these old kind of shielded type coins, which are not compatible with the Lelantus Spark coins, and effectively move them over, keeping the values secret, and relying on, some slightly more advanced, but not too much advanced cryptography to ensure that balance is maintained. So the upsides to this are that you don't have to effectively reveal balances by moving to a transparent pool first, which has some privacy and safety benefits. But in theory, technically, it does involve some risk, because any issues with balance that might arise by hiding these amounts could also extend out to this transition. So are there risks on both sides? Yes. It's kind of hard to assess which is going to be better or worse, depending on whether or not you're more concerned about, ensuring that the supply into the pool is what you expect, versus, ensuring that, users don't have to move their funds in possibly unsafe ways through a transparent pool. So those are kind of the two big approaches as to how you could do that.
Yeah.
So, I guess it'd be up to folks to decide, which of these they choose to prioritize more. I tend to think that doing so-called transparent migrations does carry a lot of risk. And it's possible to do it in ways that, might not necessarily be the safest.
I think also one of the, I guess like one example of how like migration to a transparent pool can review someone is that, oh yeah, technically it's like a Lelantus span, and then you move into the Spark pool. Isn't this the same Lelantus version 1? I think it's because the way that it's probably going to be done, like I'm going to move all my Lelantus version 1 into Lelantus Spark. So it's the timing of those, spends that can be very revealing. Because if I see like a whole bunch of spends coming out at a certain time and then all going to the Spark pool, I can make certain assumptions to say this is probably coming from one entity or one person. So that's one way that privacy can be breached. But on the other hand, for example, like this is something that also that we have to really kind of think about, because ideally, we don't really want to maintain both Lelantus version 1 and Lelantus Spark, right? Because so like there were some we haven't been able to actually concretely prove the balance security of Lelantus version 1. There's no known exploits, but then there's still like a bit of a question mark there that we haven't figured out a way to formally prove it. So, that's kind of like overhanging things, so that if there's sort of any sort of like issues with Lelantus version 1 and we don't do the transparent migration, there's this possibility that all of that gets carried over to the Lelantus Spark, and that's that's also another risk as well. So as Dr. Aaron said, it's kind of like yes, we're gonna sacrifice some privacy, and yes, there's this possibility that if there was a vulnerability, there'll be some innocent people that might be locked into the Lelantus version 1 pool, but at least you kind of know that something has happened. While with
it's again, like it's there's risks on both sides.
Yes.
Yeah, exactly. And like Ruben was saying, the original Lelantus balance proof, not the Lelantus Spark balance proof, but the original Lelantus balance proof did contain an error. I mean, at this point, we haven't identified a way that it could necessarily be exploited, but it could be that there's a more a correct security proof for it. So like if there were to be a practical problem with it, that could in theory be carried over, in any kind of a direct transition.
There could be a way to prove its security, but it's just like it's not trivial to do that work as well. And yeah,
no, it's not. And again, like that's part of the benefit of Lelantus Spark is like the balance proof is very straightforward. So so I guess in this case, like there are in theory risks to doing either of these two approaches. A soundness approach and a kind of a more in theory risky approach that guarantees you supply. But at that point, like you were saying, you have to make some difficult decisions about what happens, for example, if more funds start coming out of this pool than you expected.
Yep.
What do you do to honest users' funds? Like that's a tough question to have to answer.
I think the main difference is that you may be able to detect something's not right with the transparent migration. Like it's like
it's really tricky. It's not a guarantee. There's kind of all this like weird, maybe probably economics and game theory involved. Where if you knew about an exploit, how would you move funds in order to get as much out of it as you could? I don't know. It's a tricky process. So it's a tricky process that I think is made more difficult, by the fact that there's this proof error that kind of hangs in the air.
So I mean, we've been recently talking with our community. How should we? I mean, it's not like obviously, like this is a technical decision that maybe a layman should not be deciding on. But at the same time, we want to make sure that the community has, at least some say. We want to hear your feedback, right? And another thing is that, like, how long should we keep that migration open, right? I mean, we just opened like a very informal poll just to kind of a gauge of sentiment. We'll be probably holding more of these polls, like, should we allow the latest version 1 for 6 months, for 1 year or more? Obviously, the longer that we allow it, there's more risk. But at the same time, it also prevents people, like, maybe these people just like forgot about their Firo or didn't migrate it out. They're not going to lose their funds, right? Because it will kind of suck, like, if they were away for 6 months and suddenly, bam, they can't access the money that they properly anonymize. So we're just checking to see, is 1 year enough time, or should we have it longer? Obviously, my personal preference is 1 year, but I guess this is a discussion for another time. But it's just letting you know that we want your opinion, and we'll be holding more community polls for that. And another thing
I
that,
would
yeah,
vote.
sorry, go ahead.
Oh, sorry. Was that a question or not? Maybe
No,
I.
no, 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 no. It's just more
Okay.
of just letting people know that, yeah, this is something that we haven't decided on.
All right. Okay.
You can
Okay.
weigh on. But something I want to kind of cover is, we have been kind of discussing ways on how, we have kind of like made that decision to kind of ease into mandatory privacy rather than abruptly switching on, because we're not so sure that exchanges would immediately adopt it, especially with hardware support, atomic swap support, all this other stuff that kind of relies on the transparent address, and they had, and like even our masternode relies on the transparent address, and we haven't actually figured out how to solve all of this without the transparent address. Not saying that it's impossible, it's just some stuff that we have to figure out. I mean, you have to realize that Lelantus Spark is really brand new, but at the same time, we definitely, as a privacy coin, we really, really, really want most transactions happening through Spark, right? And perhaps only the very odd cases where maybe you're interacting in the exchange which knows your identity anyway, or you're doing some sort of functionality that we currently don't support in Spark. So some two ways that we've been trying to kind of like think about improving the sort of encourage the usage of Spark addresses is making all mining mandatorily go into a Spark address as opposed to being mineable to a transparent address. This is something that we've just been like floating around. There's nothing final about it. And another functionality that we've been also thinking about is that instead of like with a transparent address, like let's say like you withdraw from an exchange, it has to go into a transparent address right now, and then you have to anonymize it into your Lelantus Mint or like your Spark address, which is like one additional step, right? So Aram and Aaron, the Lelantus Spark is designed in a way that you can actually, from a transparent address, pay into a Spark address directly. So that means that the recipient doesn't have to do this additional step to go into this shielded pool. So
Yeah,
maybe
that's correct. There's a generic kind of Spark minting transaction, like I was saying earlier, that basically takes known transparent value in some way, and sends it into the Spark pool effectively. Like you were saying, that could be consensus rules around mining, or that could be consuming transparent outputs from a base layer with known values and then putting those into the Spark pool, using whatever signatures on the base chain already exist. And again, like in theory, it's possible to kind of do the reverse, to take funds that were in the Spark pool and throw them back out to the transparent layer. I am opposed to this idea. They're like, kind of like we were talking about, there's risks involved with, this transition that would involve moving to transparent funds. It's really tricky to, get an ecosystem, I think, to move to, safer shielded type operations if there are options for, large players to support transparency only. I don't know if that's been solved by anyone. It's, if you only have one option and that option is private, then, folks will either use that private option or just use something else. So there's cryptographic options, but, they contain, consequences that can involve risks. So I think it's really important to consider what those risks are and what the benefits might be to compensate for them.
Now, Aram,
But the cryptography is flexible enough to support such options if it were really decided that that was the right move.
Aram, do you have anything to add to that?
No.
Yeah. So I mean, this is of course my personal opinion. Like what I was thinking is that I definitely understand the argument, especially like when we're saying like if we make this mandatory, exchanges are forced to use this new addressing system, and therefore everyone's privacy improves. And I think Dr. Aaron's opinion holds a lot of weight as well, because like we have seen kind of this dual addressing support in Zcash, right? Where even with its vast resources and funding and connections, the adoption of shielded addressing and exchanges has been very, very weak. I think only a very small handful of handful of exchanges actually support shielded addressing. And I think the kind of the lesson that we can learn there is that exchanges are always going to be taking the easy way out. I mean, like if it's going to be a lot easier for them to maintain, if it's going to be less computationally, it's just less work for them, they're going to take the easy path, right?
What if we will increase the transaction fees for transparent?
Maybe, yeah, as a tax for using transparent addresses, right? Who knows, right? But I mean, right now, the way that I was thinking about it is so to kind of allow it so that exchanges can withdraw directly to Spark addresses, and that means all our wallets would only be promoting Spark addresses by default, right? And hopefully we can convince the exchanges to say that, right, you should also validate this type of Spark address as a valid address as well. And that means that from the user point of view, everything's just on the Spark layer, and the wallet will automatically, like if it detects a transparent address, it will just do that de-shielding. That means but everything else is like all Spark friendly. Of course, that's another approach. We don't know how it would turn out with of some ways, and I'm actually kind of interested to see how Zcash, unified address system really works. I'm not too positive about that, but it'll be interesting to see how adoption of that happens. I know Aaron has some very strong opinions about that.
Yeah, it's the cryptography supports a lot of things, but how that translates into ecosystem support and practical use, it's an entirely different question. So
okay.
Yeah, it's kind of takes and switches where the risk lies, right? The risk in doing so is not going to be in the math, but in how you actually interact with other entities behavior. And and transactions on the chain. So
cool. So okay, I think we're probably going to wrap this up. But I think the last thing that I kind of want to maybe are there any final thoughts? And I guess when can the community expect to see more details about Spark? The security proofs and stuff like that. Aram. Well, I guess that's you. Yeah.
Yeah. So I believe we will have something published by end of August already. So just in a week or two, the first version of the paper will be out. Mm-hmm. And then the missing parts are just format
You're kind of lagging out a little bit.
The main description out.
Maybe Aaron, let you complete that since Aram's internet is. Yeah, your internet kind of cut
Aram
off a
left
bit.
us with
Sorry.
Aram left us with a cliffhanger as his network failed at exactly the correct time.
To finish the
Yeah.
paper.
Oh yeah,
It will
yeah.
be
So I know
pretty soon.
Aram's been working on a lot of the big protocol level security proofs. And in the meantime, I've also been working on kind of some of the component level security proofs. So as Aram said, the protocol is built out of these cryptographic components. Those components have their own security analysis, and then kind of the overarching protocol relies on those as well as some different security properties. So I've been working on kind of the component level security stuff and some of the algorithms and that functionality, and then Aram's kind of working on these overlying security proofs. So I think the idea is to once we have at least the algorithms, some of their associated functionality, some of the background, maybe some of the component security proofs in a place where we're happy, to kind of put out an initial version just to give folks an idea of how the thing works, how it all fits together, while the kind of overarching security proofs are still being finalized. And then, kind of put out a more complete official version of the preprint at that time. And that would be the version, presumably, that would get submitted for, review to, conferences, for example.
Yeah.
And of course, it'd be made available.
Later.
Yeah, and of course, the whole thing would be made available, on like the IACR preprint archive, for example. So, folks don't have to, subscribe to journals to be able to see that version of it.
Yeah.
Cool. Yeah, so like if you're a researcher and you want to kind of know more, like if you're interested in contributing in some way, you can always contact me at ruben@firo.org or aram at firo.org, and we'll be happy to loop you in. But yeah, I think for the moment, just like hang tight while we publish our paper, and then I think then it'll be in a much better state to discuss stuff. So yeah,
Yeah, it's sweet. We don't want to put out a preprint that's so that's so incomplete as to not give a good idea of what's going on.
correct.
I don't think that's helpful.
Yeah. Cool. So, all right. Thank you so much, Aram and Aaron, and really looking forward to seeing the Lelantus Spark paper. I think this is a very big improvement in privacy for Firo, and I personally am very proud that Firo is one of those very few coins that projects that actually are developing like unique privacy protocols, and in doing it in a very it's a different approach, right? It's not just a copy paste of something, and we are contributing to the to the general privacy space, not just our project. And so I hope the community appreciates that, and yeah, so have a great day, everyone.
I think it's exciting. I think it's exciting to have something that can be useful, to the whole ecosystem, which is really nice. It'd be cool to see where like this protocol goes, kind of more broadly in the ecosystem, as well as to see like what other research, can build off of it. Because I think that's one of the neat parts about doing open research, is that everything builds off of everything else, and yeah, it's fun to see where things go. This is a cool area of research. Math is fun.
Yeah. I really wonder, like, if we can, I don't know. My like big hope is that we can find something better than one of many proofs and slot it in, and we can get global anonymity set somehow. That would be awesome.
Well, there is a lot of good research in this
maybe,
area,
yeah.
right? I mean, like this is not doing kind of full input ambiguity is. I wouldn't say that doing it in like the most optimal, efficient way is a solved problem, but like there has been really good research in this space. Right. So like this fits in as like you were saying, like having many different alternatives towards similar goals is a good thing.
Definitely.
I don't think there's going to be like one ultimate winner that gives you everything you want. There's always trade-offs, and I think that this is a cool approach that gives you nice benefits while understanding what those trade-offs are.
I think it's kind of like my personal take is that it's kind of sad that our blockchain privacy space is really limited to really a handful of privacy protocols, none which are none which I feel like have the holy grail, solve everything right now. So I still think that we're in a time that we should still be pursuing independent implementations and protocols. Yeah. So yeah, I guess thanks everyone, and have a great day. So yeah, I'll be ending the recording now.